Okay, you're welcome back to class. Today we're going to talk about Pythagorean triples. In the last class, I told you that we were talking about the application of Pythagoras theorem. Then I told you we have a Pythagorean triples, which we assist most of the students that is in the terminal class. So by the time you see a right angle triangle, you'll be able to get your answer very fast. If you know that Pythagorean triples, you'll be able to get your answer. As long as you see the right angle triangle, you can tell the answer very quickly, even without any wasting of time. You tell your answer very quickly. So that is what Pythagorean triple is all about. I'll give you the table. The table is there. Then just make sure you memorize the table and you're good to go. If you are new here, subscribe to my channel and like, comment, and share with your friends and family, those that can benefit from the class. Okay, don't forget to subscribe to my channel. So let's go to it now. Let's go. The following tables give some common triples which satisfy Pythagoras theorem. So these are the table. Assuming we have our rectangle triangle, let me try and draw it now. Let me try and draw the triangle so you can see what I'm talking about. So we know that if you want to use Pythagoras theorem, it must be a right angle triangle. Are we agree with that? It must be a right angle triangle. Do we get that? Now, you know, they have to indicate it there before you assume that it's a right angle triangle. So if this place is A, just like the one I showed to you while we were proving and do other things, we started a triangle. So now, this is a triangle that we're talking about, right angle triangle ABC. So this table is telling us that if A is 3, assuming we have 3 here, and our B is 4, so which means this place will be 5. The other side will be 5. That's the hypotenuse. Don't forget I told you hypotenuse is the longest side and is one that faces the right angle. Let me write this one so we won't have any issue with that. Do we see now? So the hypotenuse side will be 5. That's what this table is saying. Let me just explain the table, then I'll go to the proving of it. I will check it now. We're going to check it together. If A is 5 and B is 12, if we have 5 here, 12 here, definitely our C, the hypotenuse, will be 13. That's what this table is saying. If our A is 8, our B is 15. That's the adjacent, the two adjacent. The hypotenuse will be 17. Okay, so let's try and check it now. Let's check it so we can understand the concept very well. How do we check it? You're going to look at C. Our C is what? 25. That is 5, Abby. So let's look at that one. Our C is equals to 5. And what Pythagoras theorem says is A squared, don't forget, plus B squared is equals to C squared. That is, hypotenuse squared is equals to sum of the two adjacent side square. Okay, good. I hope you remember that. So don't let us go to that. Hypotenuse square is equals to adjacent square plus adjacent square. Now, so which means we have this one to be squared. Let's square this one now. So C squared, that will be 25. Okay, so let's look at this two ends now. We have to add it together. Don't forget, we still want to prove this thing. No, we want to prove it now. So we have A squared. That is, what's our A? 3. 3 squared is what? That is 9. B squared, that is 4. That is 4 squared. 4 squared is equals to what? 16. Then the addition of the two must equals to the square of the hypotenuse. Okay, addition of the two must equals to the square of the hypotenuse. So let's square it. Let's add it together. 9 plus 16 is what? 25. That's very good. 25. So which means 25 is equals to 25. That is what this thing is saying. Do you see that now? Is it clear enough? So don't forget, we're not going to waste time on this area today. Let's try the second part. Don't forget, we want to check this area. You start from the hypotenuse. Hypotenuse, that is C, in the second phase of the table. That one gives us 5, 12, 13. So we have to look at this square of 13. 13 square is equals to 169, isn't it? That's very good. So let's look at AB. A is 5 square. A is equals to 5 square. That is what? 25. Our B is 12 square. B, that is 12 square. That is 144. Let's add it together. A plus B must equals to 169. So 5 plus 4, that's 9. 2 plus 4, that's 6, and 1. So we have what? 169. So which means 169 is equals to 169. 169 is equals to 169. Do we get it now? So you can check each of this table, okay? You can check it and you're going to see that it's very correct. Now, another thing that you need to know is if ABC is a Pythagorean triple, then KA plus and KB as well as KC is also a Pythagorean triple. What are they talking about there? Let me explain that quickly. Because over time, let me explain that. What that one is telling us is if you use a constant to multiply these three, a constant to multiply the three. Let's look at this one. This one says ABC. According to what that thing is saying, what this sentence is telling us, K into ABC now. So that's how we have KA, KB, and KC. Do we get that? Now let's now look at the number. Let's use the number now. 3, 4, 5. So we have 3, 4, 5. That's our Pythagorean triple. So if we now multiply it by a specific a constant, a number, probably we use 3 now into bracket 3, 4, 5. We want to use 3 to open the bracket. So we're going to have 3 times 3, that is 9. 3 times 4, that is 12. 3 times 5, that's 15. Which means 9, 12, 15 is also a Pythagorean triple. Just like what we have here. Okay, 9, 12, 15. If we use 2 to multiply 3, 4, 5. 3, 4, 5. That will give us 6, 8, and 10. So just like what we have here. In essence, any of these Pythagorean triple, when you use a constant to multiply them, you are going to get another Pythagorean triples. Do we get it now? So it's just like you multiply it by a constant. So 3, 4, 5 multiplied by 4 across. 4 times 4 times 4 times 4. Whatever answer we get is still a Pythagorean triple. 5, 12, 13 multiplied by 2, 2, 2. Whatever answer we get from that is still also a Pythagorean triples. Do we get that? Do we get that? So make sure you're familiar with this table, memorize it, and it will assist you a lot in your exam. So you don't need to be cramming, or you don't need to start doing it again. As long as you see 3, 4, you know that 5 is the last one, or you see 5, 3, you know that the adjacent will be 4, like that. 5, 12, 13. When you see 5, 12 in the two adjacent, you know that hypotenuse will be 13. Do we get that? Do we get that? So see you in the next class. We're going to another topic. We're through with the Pythagorean theorem like that. Okay, so see you in the next class. Bye.